Welcome to my channel. We are looking at integral calculus, and in this video I'll give various examples that will enhance your skills in integration. So I'll begin with what we already know, that if you are given an integral of this form where n and a are constants and you are asked to integrate it, generally this is how we give the solution. That it would be, we raise the power by 1, so this is x raised to n, so it will be n plus 1, then divided by the new power, then add the constant of integration, c. So that's what we just do, and we'll look at various examples before we start doing other types of integration. So what we are saying is, when you are given the integral of x raised to n, a is any number, is any constant, n is also another constant. The integral of this, the solution to this would be, we just raise the power by 1, so it's ax n plus 1. So this is our new power, and we divide by this new power. What I've stated here is that this rule is only applicable when n is not equal to -1. So n should not be equal to -1. So what I'm saying is, we are not using this rule to do integration of this kind, where n is -1. So when n is -1, we'll come up with another rule for doing that. So let's just look at a few examples. And the first example here is, determine the following indefinite integral. And I hope you know the word indefinite means that these are integrals without limits. So we do not have, these integrals have no limits. For example, you're not saying that you're integrating from what point to what point. Now, so we want to look at these examples, and some of them are easy. Like the first one is very easy. As we said from our rule, is that we shall add 1 to the power and divide by the new power. So as seen, this a, the solution to this a, when you raise 1, when you raise the power by 1, so this is 3 by 1, and divide, so the new power is 4, divided by that 4. What you have is 7 out of 4, x raised to 4, and then add a constant integration. So the first one is very easy. The second one is also very easy. Then we just add 1 to the power, so the solution becomes 3 out of 7, x raised to 7 plus 6. So when I add, this is 6. 6 plus 1 gives me 7. So that is why I get x raised to 7 and divided by that new power. The same to this is also very easy. We're just adding 1 to the power. So let me show you my working, that I done this one earlier. So what I was getting as my workings are here. These are my workings. So for the first one, I said you just add 1 to the power, you get 4, and you divide by that 4. Then add a constant of integration. The second one, the same thing, add 1 to the power, get 7, and then divide by 7, and then add constant of integration. The third one is also that way. That's why I said add 1 to the power here, add 1 to 4. So this part becomes 7x raised to 4 over 4. And we also do this other one. Add 1 to the power, you get 3. So it will be 2 out of 9, x raised to 3, then divided by 3. And that is what you're seeing here as 2 over 27, x raised to 3, because 9 times 3 is 27. Then these are constants. There's 13, x raised to 0. 13 x raised to 0, because I know that x raised to 0 will be 1. So this is 13 times 1. So I just add 1 to this power and then divide by the new power. So this gives me 13x, and that's what I have here. Then plus c. So therefore, what you're saying is that the integral of a constant would be 17x plus c. Or for this one, the integral of a constant 13, the x is 13x plus c. So that's what I've used here, that when you're integrating a constant, just add the x. With respect to x, just add x to that. And let's look at part D of the examples. Now, so part D, I can see that this division is a division. So the first thing I'll do is to divide through first before I integrate. So what I have is 7 x raised to 5 divided by 5x squared, then plus 13 x raised to 2 divided by 5x squared, the x, the integral of this. So when I divide this, what I will get will be 7 out of 5 x raised to 3 plus 13 out of 5. These are constants, then the x. So this is what I have to integrate. This is what I have to integrate. And this is what you're seeing here, 7 out of 5 x raised to 3 plus 13 out of 5, then the x. Now to integrate this, you say you add 1 to the power. So this becomes 7 out of 5 x raised to 4, then divide by that 4. Then the other one is a constant, so it will be 13 out of 5 x, then plus c. But now 5 times 4 is what is giving me this 20. So I have 7 out of 20 x raised to 4 plus 13 out of 5 x plus c. That's how I did that. Now what about this one? Again, I have to do the same. I have to divide. So that is the same as 11 x raised to negative 3 dx. And so when you add 1 to the power, you'll have 11 x raised to negative 3 plus 1. And this gives you negative 2. So you divide by that negative 2 and then add a constant integration. And so that gives you 11x raised to negative 2 over negative 2 plus constant integration. And if you want to write this in as positive, then you write it as negative 11 out of 2x squared plus 2. You can even leave your answer at this point and it still be correct. I wanted to express this as positive, this power, the power of x as positive. That is why I've taken it to the denominator. Now let's look at this other example. And we're just trying to simplify the questions that we have before we work them out. So what is this? What I'm seeing there is negative 11 out of 3, and this means fifth root.